I gave a version of this talk, I think, like in June. This is a completely new talk, but like the idea behind it is something that comes out of like a bunch of the blog posts that I wrote. So you might, if you do want to read my blog, you might find some references of this. So I've been doing open source for a really long time, mostly in the Python ecosystem, and I left the previous company I worked for, Sentry, in April, which perfectly overlapped with a friend of mine telling me about you should really go all in on Cloud Code. And so I spent, until I fully incorporated the new company, really going deep on trying to figure out like why these things work so well and sort of give me a dopamine hit. And basically, I fell into a hole of agentic coding. And then I started writing about this. But then I also got very, very interested, like how does this actually work? Because there's one thing about using a coding agent. Another thing is like actually trying to build an agent yourself and give some sort of intuition about how it works. The whole point of this talk is really just also to preface this with, I actually have no idea. And I'm presenting this talk for the perspective of, you probably also don't necessarily have an idea. Because the way we're all working with these models is that we sort of get a black box from a foundation model provider. And now our best job is like, how do we figure out what we can do with it? And hopefully also can do this in a way that will continue to be true. And I think the good news is that seemingly also a bunch of other people that are actually working on foundation models also don't necessarily know what's going on in these things. So we're a little bit in the same boat here. So the goal is to get some sort of useful direction just in general of like how we can work with these models. So we are somewhat beholden to the model providers, and you can obviously train your own models, but there's a huge difference between, and the context here is really agentic anything, right? It's like there's one thing to go to a model and ask like, what's the capital of France, and it's going to give you an answer. But actually to have a model that is agentic, that sort of does really good tool calls, and that actually makes it through some tasks, we are not right now in a situation where we usually can train our own models. So we kind of have to work with what we have. And so we cannot look into these models. What we can do is we can make some extrapolations about like why do they work the way they work, and how can we work with this. And so we do not know the training process. We don't really know what these models are optimized for. We can get some educated guesses by reading documentation, see what special tools they have. And at one point, my feeling was like, OK, if I don't know what's going on in these models, then every time a new model comes, I sort of have to relearn this. And so there's a risk to what I'm building that it will continue, that it will sort of no longer work. And so my original thinking was like, how do I actually build something that will survive a model change, and whatever the model providers are going to do with it is not fundamentally going to change anything I'm doing. So really, it is not to guess, to find out like how do they work, but to do it in a way where we can extrapolate into the future. So that's basically the idea. Again, I don't know anything about AI in that sense. So part of this is a little bit like just catching up with how my understanding developed of like how these models work. And the most important part here actually at the moment is reinforcement learning. So you have a pre-trained model that has a sort of basic capability of answering questions, and that kind of comes out of throwing a shit ton of data at this model, and then eventually something happens. But then through a process called reinforcement learning, these models actually turn agentic. That's a sort of a simplified version of this. And basically that happens because they have some data that can be measured, that can get a reward signal on the execution. And through these extra training cycles of having actual sessions, coding sessions and other things going to this model spec, good behavior is rewarded and bad behavior should sort of be no longer happening quite as much. And so over time, as this sort of happens and continues going on, the models turn more into the kind of thing that reinforcement learning throws at them. That's sort of the short version. So one big question here is like, what do they train on? And I'm not a model provider, so this is again sort of what I pulled out of like talking to people and sort of getting a basic understanding is really what they are training on over time at this point is a bunch of session data. So when we vibe code with these models, some of our sessions make it in the training data going forward. So whatever is happening in these training sessions in the coding sessions that we're doing with our coding agents turns into signals for future reinforcement learning in these models. And so whatever happens in a coding session is more likely to show up in the reinforcement learning process than something else. Why does this matter? Well, it matters because how we are at scale using these models is actually, in a way, influencing future iterations of models, right? So if we're trying to do something that's very, very rare, it's going to be underrepresented in reinforcement learning. If we're doing something that's sort of very, there might be some compensation happening in the model provider for this, because they might want to go after some spaces that are exciting, and they're sort of specifically looking at this data. But for the most part, our interaction with the system sort of create this. This is also important because like these workflows that are actually taking place, they're kind of forcing more of this sort of fixing up of the data. And the other thing that's very interesting with coding sessions, and we're going to this, is that they're very clear to evaluate. Like there's one thing where like you do reinforcement learning on like write me a poem about a dog and a cat, and then the only sort of signal that you get is like, here I have 2 versions of it, please vote which you liked more. But coding sessions you can actually evaluate without human feedback, because you have signals at the end like was it committed, did the test pass? Like there's some mechanical things they can do. So tool using code loops are very measurable. That's sort of like one important part about this whole thing. So how could we take this knowledge and do something for the future? Well, basically we can right now sort of say that if there is a lot of data available, specifically if a lot of data is available across model providers, we can probably assume there's going to be a pretty good foundation to build on, and where you can score this very easily. And so there's some natural results coming out of coding agents being overrepresented in the test things, which is, what is a coding agent doing? Well, it's running code. It's running Bash, Python, like it runs set, it runs Perl to change a bunch of things. It knows how sort of changes by programs running influence changes to the file system. So it understands that if you run echo foo pipe into text, a test.txt, then a file test.txt was created. So it's like it over time learns this understanding. So there's a lot of like implicit behavior that comes, and that will probably not go away, even if future models come by. So this is just a very brief summary of what coding agents sort of give you gains in the base models. And this basically means like it's not just the agent doing this. It's like the model actually benefits over time from people building coding agents on it. So Unix workflows, files, diffs, permissioning systems, popular programming languages, build tools like test log, stack traces, anything that sort of is naturally read into a session will make it into reinforcement learning again. Same with incremental edits. On the other hand, there's a bunch of stuff that sort of is underrepresented compared to what you probably want. So it's like they still suck at clicking stuff in the UI, even with the multimodal models. We just haven't really gotten to that. If you try to work on some very proprietary system, it doesn't mean that they fail, but it means that if they have no clue whatsoever and the failure conditions of these systems are maybe not working as well, then they are not going to show up here. Generally, tasks that resist any sort of textual decomposition are not great. So if you want to work with binary data, if you actually deassemble it and have it work on disassembly, it's going to work. But if you have something that cannot be sort of mapped into like video files, like working with video is really frustrating right now on these models, because the best you can do is take a bunch of screenshots and then hope you can do something with it. But also what's underrepresented in this is actually agentic interactions that are volume-wise not very high, and they work with data that doesn't look like coding data. So my example of this is like actually making these agents work with observability data is really hard, because like they're very complex systems. The kind of data that makes into the sessions is kind of hard to sort of pitch together. But you get some other bonus hunches out of this. Because coding agents increasingly take screenshots and put screenshots into the models, we can probably assume that like this basic multimodal interaction is going to continue working. And we are going to, I mean, we can already see this, that like because coding sessions are overrepresented, people are now starting to build things on top of the coding agents instead of building a completely different agent from scratch. I was already sort of mentioned that I don't like MCP, but like one of the problems with MCP is that because it is basically just pulling proprietary tools into the context all the time, it's very hard for a model to reason and to create critical mass in the training session going forward to actually understand what's going on. So now we're in this sort of space where people started to realize, okay, this coding agent is really good. How do we build more products on top of it? And so if you have used Cowork, for instance, Cowork is basically taking Cloud Code as like the base execution layer and sort of putting more shit on top. So it can manipulate spreadsheets, Word files, calendars, and sort of similar workspace kind of things. because sometimes there's multiple sessions that you have to do, there seems to be an increasing amount of people that are realizing that tmux actually is sort of an old building component that's already somewhat reflected in the training data. And as more and more people are sort of automating more things with tmux, that happens. The Chrome developer protocol for remote controlling browsers is very overrepresented, and people are using that already. And so like as they're doing more browser automation, that will again go back to the training data. So anyways, these coding agents are starting to really absorb a whole bunch of like non-coding related efforts. And if you have used OpenClaw or something like this, it's a good example of like there is like now end consumer kind of applications happening. They're just built on top of these coding harnesses. Okay, I want to talk about the surprises a little bit. So the surprises are when the model actually completely misbehaves, even though it looks very similar to something that should happen, but doesn't. So the biggest one that I keep running into is that if you have state changes that are actually not showing up in the session data. So a good example of this is if you have one coding agent write a whole bunch of changes to files, and then you go in and actually make manipulations to those files as well, the model gets confused. And not only does the model get confused, the problem is also there is no indication in the session data why this file changed. And so Cloud Code at one point, and I don't know if they still do this, they actually watch file changes, and if they see that the file did change, they inject another message back into the loop saying, like, this file changed, you might want to reread it. And if you don't do this sort of setting this sort of modification messages into the agent loop, you can create some really fascinating behavior. So I have a sandbox. I had to test that the sandbox actually works. So I asked the coding agent to escape its own sandbox, right? It's like, here's, like, I placed this file over there. Please read this file. Try to do something with it. And then eventually it reads the file because like there was a hole in the sandbox. And it's like, oh, yeah, it was successful. I escaped the sandbox. So I fixed this problem. I reload the agent, but the agent doesn't know it was reloaded. And I tell it, hey, please validate that that this problem is solved. And it writes, yes, problem is solved. And here's like how I reproduced it. But I could see that it didn't actually read, it didn't execute any tools. So it just completely made up the fact that like it just claimed that it validated it, but it didn't in fact do that because it was unaware of the state change. It's very annoying when it happens. And basically there are a lot of situations like once you understand that like external state changes break this experience, it's unfortunately very easy to create more situations where the experience completely ruins. Anyways, what does it mean for us? We can basically build on top of this idea of like what makes coding agents work, the session data being shared with model providers, and then so we can go from there. Which basically means we're probably going for a while going to narrow down on coding agents, if you want it or not. And that doesn't mean like everybody should build a coding agent in order to build a non-coding agent, but it is a good way to start. And so writing code and then running code is basically a mode of execution. If we know that there's a file system and the system understands file systems and the agents know how to program, you can layer a lot of behaviors on top of that are actually unrelated to writing code. The biggest reason for why this is helpful is because you're actually surprisingly context efficient if the data actually doesn't have to travel through the context. It's probably not too surprising, but like as an example, the PyCoding agent, when it reads a file into the context, it will only read, I think, 500 lines or something like this. And then if it wants to read more than 500 lines, it drops an extra message into the context saying like, hey, by the way, I only read this much, but there are like 700 more lines. If you want to read them, do this. So the tools individually, they are like very context efficient and they're trying to not to do too much. Or like when you, in a coding agent, when you try to execute a program, and the program produces 20 megabytes of output, coding agents are starting to like only read the first 100 lines into it and then leave a message to a file on the file system where the overflow goes. And so then the coding agent, if the agent determines that they actually do want to read this file, like the rest of it, it knows where to find this file. But usually it doesn't read the file because it understands there's like 20 megabytes of data. So it will start using grep or like a more precise way of reading the stuff in there. And if your agent doesn't have these tools, then you cannot rely on that functionality, which is trained into those models over time. So anyways, I'm going to repeat myself, but like files and execution is a really convenient way of doing this. And I, for a while, was trying to fight this idea that everything turns into a coding agent because it is actually, in many ways, sort of not what you want. you have this idea like you provide a bunch of custom tools and it's going to magically work, and unfortunately, it doesn't seem to be the case. So instead, my approach so far has been to build these tiny programmable worlds. And since we're at sort of Pydantic sponsored event here, one of the things, for instance, that Samuel released is Monty, which is basically a custom mini Python that you can sort of use as sort of execution layer. There are many other ways in which you can sort of attempt to sandbox something. There's container to WASM. You can run micro VMs. You can run PyAI, sort of. It's very hard to sandbox this, but there are many alternatives to not having code execution at all. And obviously, a lot of people are trying to do that. But it's an interesting sort of starting point to give it just some basic code execution. And to then really narrow down on files. Particularly if you build a little agent, having a virtual file system is a great way of like sending data between different iteration turns on the loop. Yeah, and basically, like for as long as you stick to what the coding agent is doing, you have a very good starting point. This is probably entirely unsurprising, but if you are sticking to something that the agent roughly already understands, you have a lot of data to work with. So I did a bunch of tests for observability data. Nothing beats SQL, unsurprisingly. Like if you have your data and say like, hey, agent, please write some SQL to get the data. It's significantly better at if you give the agent a custom DSL and like a fancy UI, like human-ish query language that's simplified. It just doesn't have enough understanding compared to this. I did a bunch of tests with, I mean, this code is cheap now. Everybody can build in an afternoon an experiment if they want to. Something that looks like JavaScript works better than for instance, scheme-like language. Or Lisp, for instance, I discovered this just doesn't really work because it has to balance the braces and the parentheses. And it's a strawberry problem. Like they tokenize really badly and then sometimes it miscounts. But so anyway, working with something that's sort of very, very common works really well. And the trick then also is that when you are actually not giving it regular Python, you give it like a fake Python, like Monty, or you give it like a mini JavaScript, when it actually emits a syntax construct that it doesn't actually have in your mini language, instead of just erroring, you produce an error message that says like, hey, this is a mini version of JavaScript. It doesn't have, for instance, a class. And then the coding agent actually realizes that, oh, I guess I can't do this, and sort of it gets the feedback from the execution, go back to something that works. OK, so now that we have hypothesis, how do we test this? I'll be very quick on this. What I usually do is I ask the model, how would you solve your problem? They actually have some capabilities of introspection. If you don't believe me, there's some papers on this. They're not perfect, but you can actually give an agent, like, how would you solve this? You can run it 20 times as you want and sort of rank the results that it gets. Then you implement this. And then the trick is to go back to the agent with the sessions that it actually had and tell it, while you claimed that it did work, you're struggling with the thing that you recommended as a tool harness. Let's see if we can learn something from basically that loops. And so you can actually use your own traces. And I think this is an interesting aspect, because if you use Claude or if you use Codex, Py, any of these coding harnesses, they actually store the sessions on disk. And so if you keep programming with them for a little while, after about a month, you have an enormous amount of session traces on your own that you can point your own agent to as a sort of an input. And if the agent that you're building is rather close in structure to a coding agent, then even if you don't have your own coding, your own traces to sort of go by, you also have a lot of actually meta traces from like building your agent in your coding agent that you can use as an input. And there's a surprising amount of really useful data in it, because like usually failures are very easy to catch. And so from the failures, you can also learn a little bit. So for instance, we're here at the Python conference. You've probably figured out that the thing is incredibly terrible at using UV. It will keep going back to not using UV. I made various different attempts of trying to trick the thing into running UV, and it just will fail. But like over a while, you can take all the traces and say like, hey, please parse down your trace files, and then make some estimated guesses of why you keep failing using UV. And then it doesn't really perfectly give you a good answer to why it happens, but you can see more of the failure cases where it stopped using UV and where it did. And I'm going to pitch more on Py, the coding agent, which we all use. But what's interesting about the Py coding agent is that it has only 4 tools. It's the most minimal set of coding agents you can use, and it still works. And so you have a very small starting point where you can actually explore while writing your own agent, what you actually need. And it turns out very, very little. Anyways, the trick is not just to find out, it's find out with a way to extrapolate. And that's basically the entire idea here. And if you want to learn more about it, you can also go to my blog, which is, you can Google, where I usually write about these things, and maybe this is helpful for you. All right, and I don't know how much time I have for questions still, if I have at all.
Go on.